Hey, the class, we're here today. We're going to look at an example. This is example 4 from our notes, and it is basically a car being pulled by a truck, and they attain some kind of acceleration here. So basically, what I see happening here is we have this car, some kind of disabled car. Its mass is 1,400 kilograms. We have a truck. These two things are connected via a rope, and they attain this acceleration here. So I guess the first thing I'll do here is we'll call this direction positive. Okay, let's define our direction here, the positive x direction as the positive direction. The next thing I'm going to do is I'm going to start to look at the free body diagrams of the objects. So we have a truck. Gravity is certainly going to pull that truck downwards. So we have a downwards force here, the force of gravity. We are going to have an upwards force. Okay, we're going to have an upwards force, and that's going to have to be an upwards force. That's called a normal force. And that is going to be equal and opposite. Now, mind you, that's not an action-reaction force, but it is equal and opposite. We'll talk about here in just a moment why. We are also going to have a force this direction. Okay, maybe we want to call that an applied force. And we're going to actually have some force pulling it back. Now, we were to ignore resistive friction in this problem. So there is no friction pulling backwards on this. And again, that's for another time. But this is basically the rope that pulls back. So what I'm going to do is I'm going to actually pause the video, and I'm going to actually do the on-by notation for all of these forces, and we'll talk about that in just a moment. Okay, so here we are. I've just come back with the on and by notation for each of these forces. And I've red flagged 2 of them, not because they're wrong, but because I want to talk a little bit about some common misconceptions about these kind of situations. So first of all, there's our standard force of gravity. And again, this is caused by the Earth, the entirety of the Earth that pulls it down. The truck is also pushed upwards by the ground. This is the ground that's directly underneath the truck, and that pushes it upwards. Now, the reason these two are equal and opposite, like I said before, is because our acceleration is to the right. So that means our upwards and our downwards force have to cancel out because our net force is not in an upwards direction or downwards direction. It's actually in a rightwards direction. Now, these other 2 forces that I want to just briefly mention here, where people go wrong, let's start with this one here, this tension. Students will often want to say this is caused by the car. Now, I don't disagree. With the car not being there, this force probably really wouldn't exist. But the car itself is not touching the truck. So it is more correct to say that it is the rope that pulls on it. Okay, so we're going to get rid of that red flag because it is the rope that it does in fact pull backwards on this truck. Another thing, a lot of students will want to say here in this forwards force, they'll want to say things like it's the engine, it's the transmission, it's, you know, whatever, the tires. Okay, all of those things are part of the truck. Okay, that is the truck system. The truck system is combined of those tires, the transmission, the engine. All of those things, again, are important to create this force, but what actually creates the force itself is the interaction between the tires and the ground itself. So again, another red flag we're going to take away because it is in fact the ground that causes that force. Okay, next up, what we're going to do is we're going to talk a little bit about a free body diagram for the car. Now, the car, again, is a little bit less massive than the truck, so its gravity is going to be a little bit less. So this is on the car because of the Earth. And again, likewise, it's accelerating to the right, so the upwards normal force here, the upwards normal force has to be equaled and opposite in direction. Again, not an action-reaction, but this is on the car because of the ground. And we do actually have a force that pulls it to the right. And in fact, I'm going to talk a little bit about how big this should be. Basically, this tension, okay, the rope is what's actually pulling on this. The car is disabled, so it's not actively trying to make itself go. It's this rope that the truck is pulling on that's going to make this car accelerate to the right. And in our ropes, we assume that the tension is constant throughout. So basically, I'm going to draw the same magnitude force that I did on the truck, but this time it's on the car. Now, these are not action-reaction. A lot of students want to say that these are an action-reaction. Car by the rope. And again, if you look at why, it's basically because we have three different objects involved here. Car, rope, truck, rope. There's three different objects. These are not an action and reaction. Okay, what we're going to do next is talk a little bit about a problem-solving strategy. Okay, so let's recapture kind of what we're trying to find. The first thing in part A is trying to determine the net force acting on the truck. And part B is determine the force that pushes the truck forward. Now, I'm going to red flag this, again, not because there's anything wrong with the work here, but I want you to beware here that something students will often do, they are saying, well, isn't the net force and this force that we're talking about here, the force that's pushing the truck forward, aren't they the same thing? And no, they actually aren't. And let's take a look at why. So what I've done here is I've drawn a net force diagram. In this case, it's pretty much the net force vector that I use here. But what we have to remember is the net force, okay, the net force is a combination of all the forces. Okay, it's all the forces that act on an object. So we have the normal force that's acting on this object, plus the gravitational force that acts on the object, plus the applied force that acts on the object, plus the tension force that acts on this object. Okay, so the net force is the combined effect of all of the forces that we've drawn over here on our free body diagram. Now, as we discussed before, the two of them, okay, the two of them here, that's this normal force and gravity, these are going to cancel, okay? And again, mathematically, they're going to be equal to the same number. Vector-wise, they pretty much, one's down, let's say 10 newtons down, and the other one's 10 newtons up. So these are going to cancel out. So ultimately, what we're really worried about are the applied force and tension force. They are what actually make up the net force that we're concerned about. So basically, in part A, I truly do want to find the net force. Okay, this is the net force acting on the truck. So this is what I'm trying to find here. For part B, again, it's not the net force. What I'm actually looking for is this applied force. Okay, it's the applied force right here. So the applied force is what I'm looking for. And part C, I have to go back up and reread it. Part C says determine the tension in the rope. Okay, so determine the tension in the rope. So in part C, what we're trying to figure out is the tension in the rope. All right, let's come up with a strategy on how we are going to find these three things. Okay, so a good place to start after we've drawn free body diagrams is we think about net force equation. Now, this isn't always how we're going to approach this, but I think this is always a good starting point. So our goal is to find this value right here. And what we would need to find that is the mass of the object. In this case, it's the truck's mass, which we have. So check, we have it. And this is the acceleration of the truck. And we have that as well. So check. So basically, this net force here, okay, this net force should be relatively easy to find. We're pretty much taking the mass of the truck and the acceleration of the truck, and we will find the net force acting on the truck. All right, so this is a pretty straightforward calculation. We have our 2,000 kilograms. That's the mass of the truck. We have the acceleration of the truck. And pretty much when I do the calculations, I end up with 4,280 newtons. And again, that's in a positive direction because the object is accelerating in the positive direction and therefore must have an acceleration in the positive direction. All right, next up is parts B and part C. I'm actually going to do that. I'm going to solve these in a different video. They do take a little bit of explanation, and I would like to spend some time talking a little bit about that. So we're going to do that in another video, and I'll put the link in there for you so that you can go right to that. Thanks for watching.